Okay, so my name is Mansi Tripathi. I'm a research scholar at IIT Madras. So I am the TA for this course, Water and Wastewater Treatment. I hope all of you have gone through the lectures for the first week. So, see, what we'll be doing is we'll be solving few questions which will help you with the assignments as well as with the exams. And in case of any doubts, since we are research scholar in the same field, we are from environmental engineering field, water and wastewater treatment is our thing. So, in case of any doubt, you can ask us. So, for your information, there will be three this kind of session. You can join any of them. You don't have to join all three. You can join any of them. Two will be on Mondays. Yesterday it was, and one will be today. So three different TAs will be there, but the matter will be almost same. So you can join any of them. Okay. So we'll start now. I'll share my screen. We'll be seeing few things, we'll solve some questions, and I hope you will interact. And you can answer these questions in the chat box, or if you want to say something, you can say in between also. So I'll share my screen. I hope you can see the screen. So, welcome to the course Water and Wastewater Treatment. So, in this week, all the problems that we will solve will be from week 1. But in case you are little further, you are going fast, and if you want to ask any questions, you are more than welcome. So, this is my intro that I am research scholar at IIT Madras, and I'll give you my website also. So, in case in between the week, if you want to ask any questions, you can ask. So we'll go to the course introduction. So in this course, for this week, we have studied about what is wastewater, what are the wastewater sources, as well as wastewater types. Am I echoing? I'll check. I guess there is some echo. So yeah, we are back. So we'll be talking about what is wastewater, what are the wastewater sources, what are the types of wastewater, and then we'll go to little technical things, that is what we call mass balance. So first of all, what is wastewater? So we can call it wastewater, or it is a just a used water. That is important. So whatever the activities we do in our daily life, from drinking to washing clothes, washing home, cars, or gardening, anything, we use some fresh water, we use some good quality water, and after all this activity, the quality of the water deteriorates. So at that time, we call it wastewater when it is no more useful. But sometimes what can be done to this wastewater is what we will know in this course. So this wastewater can be reused as well. if after some particular degree of treatment, depending upon what kind of reuse you want, if you want to reuse the same wastewater as a drinking water, the level of treatment will be very, very, very high, and it will be very costly as well. And if you want to use the wastewater for some simpler purpose, like if you want to go for gardening, then we have to remove some big particles that we call particulate matter from the wastewater. We will remove some pathogenic organisms, and then nutrient will be there. We can use the same water for the gardening purpose. So wastewater is not wastewater. Wastewater in one sense can be important or raw water for other work. So when we say wastewater, we mean used water. Okay, so that distinction should be very clear. Also, you might have seen this thing very often. Now, our research scholars, professors, and every people, like most of the people in big society, they are saying, let's stop calling wastewater a wastewater. Let's just call it a alternate water source or used water. So that will remove some apprehensions from using that water. So from where this wastewater is coming, okay, we have already discussed there are many activities that we do from where this wastewater is coming. So the wastewater can be of domestic source, means whatever activity we do in our houses. The other source can be industrial, and um, like since this will be a mostly of discussion class, okay, so you can either say in class, or you, if you want, you can put any inputs in the text itself. You can use the message window and you can give your inputs. That will be very good. So talking about water sources, it can be domestic, it can be industrial. Are there any other water sources? Hmm? One will be agricultural water sources. After irrigation, there will be a huge water uh, discharge containing lots and lots of nutrients, means from fertilizer. It may contain some pesticide as well. Okay, so which is used for killing the pest in there, but we use in excessive. So this pesticide may end up in the our rivers, which can be eventually a drinking water source. So that's why we have to take care of all these things as well. Now coming to wastewater types. So what are the types of wastewater? Only these types are written here, but there can be many types of wastewater. Black water. Black water contains the feces. Okay. Grey water may contains kitchen or bathroom wastewater, but without feces. And same heavy light gray water. If the organic content is very high, it's heavy gray water. If the organic content is little less, it is light gray water. In the same sense, we have yellow water, which means it will contain urine. So there are various types of wastewater that we can define. Finally, we have already learned about mass balance. Like sir has taught in the class, so I assume you have learned about it. If not, when we will solve question, you will understand it more. So mass balance. So what is mass balance? If you have a particular control volume, if something is coming inside, let's say some 5 kg thing is coming inside, 2 kg thing is going outside. So what is happening to this 3 kg? So this is very important. This is where we learn about mass balance. What can happen to this 3 kg? Depending upon what we are talking about, if we are talking about 3 kg sugar, if we are talking about 3 kg sand, so if it is sugar, it will be dissolved. If it is sand, it will settle down at the bottom. So this is mass balance. Means you should have idea about what is happening to a particular mass of the species or mass of anything you are talking about. If you're talking about sugar, we should know what is happening to every gram of sugar. When we are able to do this balance, this is what we call mass balance. So in environmental engineering or water wastewater treatment per se, this mass balance is very, very, very important. All the concepts, all the things. So this is the most basic thing you should understand. If you are understanding the mass balance properly, then there won't be any numerical problem that you are unable to solve. So this mass balance is very important. So in case of any doubt, you please ask in between. Well, now next we'll solve the questions. So this is question number one. You can answer in the chat box or you can say also. With respect to London cholera outbreak, how was the water treated to control the epidemic? So in the first lecture, sir has taught about many, many, many things like many London cholera outbreak, as well as you might have already known many disease outbreak during COVID times. There were not lots of news channels as well as newspapers which were giving information about very very old disease, some cow disease, some black disease. Okay, so this is one of those disease which made us understood that we should take care of the germs which are around us. So if you can answer, that will be very good in the chat box or try to interact. Anything is fine. So since I have received one answer, we'll see the answer. So it is chlorination and sand filtration. So what See, when we will solve each and every question, we will talk about each and every option. Okay. Then you will understand this more. So, what is this chlorination? What is UV? What is sand filtration? And what is reverse osmosis? See, first of all, this reverse osmosis and sand filtration is kind of filtration technique. C and D, they are filtration technique. Means there will be something, let's say a sheet, there will be some holes, bigger particle will retain and the smaller particle water will go. So this is the problem, this is the concept of filtration. So in reverse osmosis as well as sand filtration, this thing is happening. But in chlorination and UV, we will understand it later, we will develop an understanding. There is a process called disinfection. Disinfection means killing of the pathogens, pathogenic organisms. There will be small microorganisms. By using these process, chlorination or UV, we will try to kill it. So how do we kill it? When we talk about any microorganisms, it will have some layers. If there is some way we can break this layer, the inside material will come out. Okay. When inside material will come out, the microorganisms is gone. Means it won't be able to do any harm to us. So chlorination and UV are two such technologies that are used to remove the microorganisms or the pathogenic microorganisms particularly. UV is a physical process. UV means ultraviolet light. So here we will use a light that will physically harm the cell, outer cell wall. And chlorination is a chemical process. Here we will use some chemicals, mostly hypochlorite or chlorine dioxide. These things we will use, which will chemically react with the outer cell wall, and it will kill the microorganism. So this is how it works. So older times, UV's chlorination is very old technology and sand filtration also. So they used these technology to treat the to control the epidemic. Like sand filtration, they removed very big particles, and by chlorination, they killed all the microorganisms, harmful microorganisms or pathogens that were present in the water body. In case of any doubt, you please ask. We'll move towards next question. Turbidity Turbidity gives us an idea about dissolved solids, BOD. I hope you know the full form. If you know, please write in the chat box. Suspended matter and nitrates. So, turbidity. What is turbidity? It is kind of if you have a glass of water, if the water is very clean, good Arpit. If the water is very clean, you will be able to see through it. But if the water is not clean, you won't be able to see the next side properly. So that is what we call turbidity. If the water is not clean, we call it is turbid water. So why this comes in the water? By dissolved solids, BOD, suspended matter or nitrates. I hope you can answer this question. Please answer in the chat box. Yeah, let's see. So the answer is suspended matter. Okay, see, I'll explain by an example. When we take a glass of water in a transparent glass, one example of dissolved solid is salt. If we will put our home common salt inside that, you will be still be able to see everything very clearly. Okay, so dissolved solid is not the problem. Coming to nitrates, there nitrate is also a type of dissolved solid. Okay, so nitrate is nothing else but a type of dissolved solids. We know one salt, NaCl, sodium chloride. So there are many other salts, sodium nitrate, sodium nitrite. All these are kind of salts. So when we will dissolve this, there you will still be able to see very clearly. So dissolved solids are not the problem. Coming to BOD. So BOD is, we can say it is of two types. BOD means biochemical oxygen demand. It represents the amount of organic matter present in the water body. So BOD can be suspended and it can be dissolved. When the BOD is suspended, it can give turbidity, but when the BOD is dissolved, it won't give any turbidity. So, but in general, when we talk about BOD, we talk about dissolve only. So that is why turbidity gives us idea about suspended matter. So eventually, even if we are talking about suspended BOD, we are talking about the suspended matter. So turbidity is all because of suspended matter. How do we test the turbidity? We will just take a glass, we will fill it with the sample, we will put light here like a torch, then we will try to see the light from 90-degree angle. This is eyes. I have to write it because the drawing is not very good. So we will try to see it from the 90-degree. The moment this torch is not visible to us, we say the material is completely turbid. Okay, and the visibility of the torch is correlated with the turbidity of the solution. So you will get a chart which will give us the value between visibility and the turbidity. So you will check the visibility and you will know what is the turbidity at that time. Okay. So this is how this turbidity is checked. So turbidity is checked always at 90 degrees. 90 degree of the path of light. So that is very important that you should understand. Coming to the next question. Question number 3 is select the reasons why we choose coliform as an indicator of pathogens. What are pathogens? First of all, can anyone answer?
Pathogens are bacteria. mm,
And
Disease causing bacteria, ma'am.
correct, correct. See, first of all, I would like to tell you if there are 1000 bacteria on a table, okay, 999 are good bacteria. Okay, just one bacteria will be bad. So that bad bacteria is called pathogens. So that is very important. Most of the bacteria are very good, and we have no problem with those bacteria. We are eating curd because of those good bacteria. We are eating cheese. We are eating many things. Wine. These are because of good bacteria. Okay. So bad bacteria means disease causing bacteria are called pathogens, and we want to kill only them. We are not interested in killing good bacteria. So I will give you two terms. One is sanitization. Sanitation, or second is disinfection. Can anyone tell me the difference between these two words? Sanitation and disinfection? Any idea? I hope you know meaning of these two terms.
Disinfection is process of killing the pathogenic bacteria, ma'am.
Yes? And sanitation?
Sanitation.
Sanitation is the process of preventing the bacteria from.
No, no, no. Okay, I'll tell you. When we say I have sanitized, see, this is mouse, I'm saying I have sanitized it. It means I have killed all the bacteria. Good, bad, everything I have killed. And when we say disinfection, we are killing only bad bacteria, pathogenic bacteria. So that's why when we use sanitizer to clean our hands, we are killing everything. Okay, that's why we call it sanitization. And when we are using a disinfectant spray on a surface, any non-living body or any surface, we are killing only bad bacteria. That is why, if you have noticed, sanitizers are costlier than the disinfectants, because sanitizer will kill everything, good, bad, everything, and disinfectant means it's going to kill only the pathogenic bacteria. So that is the difference between sanitation and disinfection. I hope it is clear now. Okay, so let's get back to the question. So why we choose coliform as an indicator to kill pathogens? Okay, let's talk about coliform also. What is coliforms? Okay, I'll tell. Coliforms are the type of bacteria which we have used to check the pathogens present in the water body. You guys are already seeing the answer. First of all, see, if in any water body, if you are taking a water body and if you find that there are coliforms, especially the fecal coliforms, then where these coliforms are present, they are present in the intestine of warm-blooded animals and humans. So it means how this coliform will end up in water body if we are putting our feces in that water body. So that you can understand, okay, coliforms are there. It means someone has discharged his or her feces in here, animals or humans. So that is the indicator of pathogens. If in any water body coliforms are present, it means pathogens are present. Okay, that is first thing. So that is why, if there was if there are even no pathogens, like I can I'll give you an example. This is a timeline. You say February. Today is February and March. Uh, sorry, January, or let's write December. If someone has discharged feces in December, it will increase the amount of coliform. And if you are checking the water body in February, then in between, it is possible that pathogens are there. Between December to February, pathogens are there, but they died. While just say in January, pathogen died. Pathogens were there from December to January, but January 1st, January, all of the pathogens are solved. They are finished. But still, coliform will be visible in February. So that is also one of the reason that we use coliforms. Second is we don't want to measure pathogens. First, it is very difficult to measure pathogens. Second, if we are taking the pathogens, we are going to our labs, we are measuring it. What if suddenly or out of accident we just keep those hands in our mouth or on our body? It will be difficult to survive after that. That is why we choose coliforms, not pathogens. And coliforms are not pathogens. Coliforms are just the bacteria present in the human body. And from this diagram, it is also clear that they can be measured till long run. Even if the pathogens are absent, coliforms will be there. So that these are the reasons. That's why we use coliforms as an indicator of pathogens. But coliforms itself are not at all pathogens. This should be very clear. So here we learned two things. First is the difference between sanitation and disinfection. Second, coliforms are not pathogens and their life is more than the pathogens. That is why we use coliforms. We'll move towards the next question. So the first question is select the correct sequence of typical wastewater treatment plant. We are releasing the wastewater. Okay. So how this wastewater is being treated in our treatment plants? What can be the sequence? Okay. More answers if there is someone who can answer this.
Option A, ma'am.
Yeah. Option A. Okay. Okay. We'll see. So yes, the correct option is A. So this sequence, you don't have to remember it. You just have to understand it. See, if I'm giving you a bottle full of wastewater, there will be sand. I'm giving you a bottle. At the base, there will be sand. Above that, there will be some turbidity. And above that, on top of that, there will be just water. So I'm giving you this thing. So first thing should come into our mind to remove this sand because this is looking very black. Let's remove it first. So how this sand can be removed? It is very heavy. You can see in this bottle, it is settling down at the bottom. So it means it is heavy first thing. So first of all, what we will do, we will remove this sand. So this can be done at dirt removal, means dirt chamber. Here we can remove inorganic particles, means sand, mud, these things we can remove. Now sand is removed. Second thing, what we can remove is small or big organic particles and small inorganic particles. That can be done in primary sedimentation tank. Small inorganic and some organic. Here we can remove some organic. This we can do at primary sedimentation. Now sand is removed, all the inorganic particles are gone, some big or some organic particles are also gone, but we want to free it of all the organic particles. Okay, then comes for biological treatment. In biological treatment, we use nature, means we use bacteria, we use algae, or any biological treatment that involves microorganisms, aerobic or anaerobic, to treat to remove all the organic particles that are present in the water body. So we use biosecure methods to remove all the organic material. Here what is the target? Organic material. Here organic material is the target. After removing the organic material, what we will do? We will just do a phase separation in the secondary sedimentation. Here we will put the treated material in a sedimentation tank so that water can be above, and if there is some sludge it may settle down at the bottom. Then we can happily use this water. So this is how secondary sedimentation work. Primary also this thing is happening, but water is little bad, and the secondary sedimentation water quality has improved a little. Okay, and this is the basic treatment. After that, there will be more treatment. Like if you want to use water as drinking water, you have to do tertiary treatment as well. If you want to use water in agriculture, you have to do very different type of treatment. But this is the basic thing. This will happen at all cost. Like different types of biological treatment can be there, but this is gonna happen. Okay. Next, move towards next question. Question number fifth is select the correct statement regarding public water and wastewater system. You can answer this question in the chat box. We are talking about public water and wastewater systems. Okay, we'll see the answer now. So answer is A, C, and D. So typical domestic water uses includes domestic water means I have already told you water from home. So at home what we will do? Flushing, bathing, laundry, kitchen. So these things are domestic water. Second option was for design of city we assume 75% of the water supply will end up in wastewater treatment plant. Okay. So this is also correct, but this is like 75, not only 75, but it may fluctuate. Okay, so
And
this is
generally, 80% is suggested by the CPHEO manual.
yeah, but it will be different for different cities, and it will be different for the different water supply connection. For example, if there is some society in which water is coming from morning 6 a.m. to 10 a.m. and the evening 6 to 8, then the wastewater generation will be very different from the society in which water is coming whole day. Okay, so yes, your option is correct. Like when we talk about when we will talk in sense of CPHA manual, it will be 80%. That is correct. But for your knowledge, for understanding, you should understand that it depends from very good quality 70% to 90%. Okay, sometimes 90% is also wastewater. So this is for your own understanding. Yes, but this 80% thing is there. Even when we design in our classes and all those things, we do 80% only. So option C is water demand for a city is not constant. It varies over different period of the day. This I hope you can understand. In the morning, more water will be used for bathing, cooking, everything, washing. In the night time, like 2 a.m. to 3 a.m., no, very less people will take bath. So the water consumption will be less. So wastewater development generation will also reduce. Option D is at the beginning of wastewater treatment, we need to equalize the flow to prevent shock loading. Yes, that is 100% true. If in wastewater treatment, as you have seen, we are using the biological treatment. The shock load is the problem, major problem in the biological treatment only, because here bacteria are working. If suddenly you are putting so much of the pressure on the bacteria, all the bacteria will die. So that is why we give similar kind of atmosphere to bacteria. That's it why excess water we will store somewhere and we will release slowly to the bacteria. So bacteria are very sensitive. So the main problem for which we need to equalize the flow to prevent shock loading is mainly for the biological treatment. Other things can handle it because anyway we will make some extra, like construction will be some extra. But for the bacteria, this thing should be taken care of. So this is the numerical. The concentration of magnesium sulfate in the solution is 240 gram per liter. Its concentration in moles per liter is there anyone who can answer? I'll give you 2-3 minutes. You please try to solve this question and you can answer in the chat box. Okay, we'll see the solution now. So the solution is, what is when we say we want to measure the concentration in moles per liter, what moles is mass upon molar mass. What is molar mass given? Magnesium plus sulfate, Mg plus SO4. So this is 24 plus 96, 120. So this is what you got as 120. Second, mass is already given, 240 grams per liter. And this is grams. This 120 is in grams per mole. So what is the molarity now? 240 divided by 120 means 2 molar. So this is 2 molar. In case of doubt, you please ask. We'll move towards next question. You can, in case you have doubt in any previous question that we have solved, you can also ask. We'll take that in the end. If not today, then we can take that in the next class. Coming to question number 7, one more numerical. 100 milligram per liter calcium in present is water sample. Convert the concentration to milligram per liter as CaCO3. This is, we have 100 mg per liter of calcium. We want it in terms of CaCO3, calcium carbonate. Let's assume this is X. So what will be this X? I'll give you 2 minutes to solve this question. It's very easy. So you please try, answer in the chat box, or you can say the answer also. Then we'll see the solution. Okay, we'll see the solution for this question. Please match the answers with yours. So, here the concept when we want to convert one species to another species means we wanted to convert calcium to calcium carbonate. In such cases, the concept of equivalent weight will come. So, two equivalent weight should be similar. Equivalent weight for this and equivalent weight for this should be same. So, what is equivalent weight of calcium? 40 divided by 2. 40 is molecular weight and 2 is the charge. So, this is equivalent weight. What it came? 20 gram equivalents. And equivalent weight of CaCO3 is 100 molecular weight and 2 because when this equation will be separated it will give, I'll show you, CaCO3. When this equation is separated it will give Ca2 plus CO3 2 minus. So equivalent weight is again 2. Yeah, this denominator is again 2. So it came 50 gram equivalent Q. So 50, I told you both the equivalents will should be same. So 50 gram equivalent of calcium is CuCO3 is equal to 100 milligram of calcium into one equivalent. Okay, so question was to check for 100 milligram per liter of calcium. So both the equivalent you got. So this is equal to 100 mg per liter of calcium. So when we will multiply it with this 20 gram per liter, we will get it in terms of calcium carbonate. It is written like this, so it's difficult to understand. But if you will write it in form of numerator and denominator, then it will be very easy to understand. Here it will be. So I'll write it clearly when I'll upload this solution, so you will be able to understand it nicely. So we'll move towards next question. For the previous question, I'll write it in a better way. Then I'll upload. Then you can see it. So question number 8 will be the principle behind mass balance is that mass which comes into the control volume. I have explained this in the very first slide. Mass that comes into the control volume has to go out or is to transform. So the mass is conserved. So is this the principle of mass balance? So if this solution is if the answer is true or false, you please try to answer this question. Yeah, correct. So the answer is true. I've already explained, I'll explain it again. If we are talking about a control volume, if something is coming in, something is going out, so about the rest of the thing, it has either transformed or in any form, it can settle down, it can evaporate something, but we should take into account all these things. So then when we are able to take account of every gram of thing which is present in this control volume, then only we can say mass is conserved. Okay, so the option is true. Let's move towards next question. Question number 9 says, select the odd one out among the following. So you have to try to find out the odd one. Domestic wastewater, municipal wastewater, storm water and sewage. Okay. Why this is odd one out? Please try to answer.
Because stormwater is different, it does not contain any kind of organic matter.
All of them are wastewater.
Yes, storm water is basically rainwater. It is not created by us. Okay, first thing is it is not generated after use. It is not used water. Okay, that is why it is different. Stormwater is not used water. It is a good water source actually. If we can do proper rainwater harvesting. Okay, so that is why it is odd one out. So question number 10 is, in addition to water, a wastewater typically contains nutrients, organic matter, microbial pollutant, or all of the above. What can be the answer? Very good. The answer
All.
is all of the above. It may contain nutrients and nitrate, phosphate, ammonia, all these things. Some micronutrients also. Organic matter, yes, we know, we measure it in terms of BOD. Microbial pollutant, yes, of course. Pathogens were there. Good bacteria, bad bacteria, everything is there. So, answer is all of the above. Moving towards next question. Outflows from which of these household unit contribute to grey water? I have already explained, but you try to answer. If you let's see if you remember. Okay, others please match the answer. So the answer is correct. Bathroom and kitchen tap. Okay, so this is what we call grey water. Toilet is black water. Correct, very good. Toilet is black water. Moving towards next question. Which of the following sentences are not correct about non-point source of pollution? Now, non-point source. There are two sources of pollution: point source and non-point source. For any pollution source, if we can identify the source very clearly, okay, this is the river, this is the river, pollutant is coming from this point, then it is point source. And if we say this is the river, pollutant is coming from somewhere big area, then this is non-point source. So, which of the following sentences are not correct about non-point source of pollution? You can answer the question in the chat box. Discharge is controlled, difficult to monitor, difficult to determine dispersion rates. Examples include salt from irrigation practice and acid mine drainage. Let's see the answer. Answer is discharge is controlled. So this is the only non-correct statement. It is of course difficult to monitor because we don't know from where it's coming. It's coming from a very big area. Difficult to determine dispersion rate, at what rate it is coming, how is the rate the pollutant present in the system is dissociating or integrating, we don't know. So one of the example is salt from irrigation practice. How this salt comes in irrigation practice? It can be fertilizer, it can be pesticides, insecticides, all those things, and acid mine drainage. Okay. So these are the non-correct statement is discharge is controlled. Discharge is, the correct statement will be discharge is uncontrolled. So the question number 13 is, domestic wastewater does not include which of the following? Very similar to the previous question. You can answer the question in the chat box. So the answer is correct. It may contain heavy grey water, it may contain brown water, it may contain light grey water. But storm water, it comes from nature, rain. All water comes from nature, but this is pure source of water from nature, rain. So this is our next question. Which of the following statement is not true regarding agricultural wastewater? Please try to answer this question. We'll see the answer. Very high organic carbon load. Okay, why? In agricultural wastewater, it's coming from agricultural fields, so it will contain sediments. Sediments is what? Mud, sand. Depending upon the terrain in which crops are grown, the water coming from those crops cropland will contain sediments. It is usually rich in nitrogen phosphorus. Why? Because we are using fertilizers. Fertilizers is the source of NPK, nitrogen, phosphorus, potassium. This is the common composition of fertilizers. So it is giving nitrogen, phosphorus. Okay. It will be highly turbid because sediments are there, many suspended particles are there. If you understood the first question, turbid, how it is turbid? Suspended particles, suspended solids, we can call them. And the D is very high organic carbon load. No, it will contain more green. Okay, one thing here I want to explain. Uh, Carbon and nitrogen. When we talk about nitrogen, things will be mostly green. Yeah, you're saying something? Okay, no problem.
I have a question.
Yeah.
Uh, if any farmer is using manure as a fertilizer,
Yes.
like cow dung manure,
Yeah.
will that contribute to the organic carbon load?
Yeah, correct. It will give organic carbon load, but not very high. Yeah, this statement is talking about very high organic carbon load. It won't be very high. Okay, but it will give contribute to nitrogen, it will contribute to phosphorus, it will contribute to carbon also. Anyway, even in fertilizers, we will see carbon carbon chain. It will also give some carbon, but not very high carbon. High carbon, when we talk about high carbon, it will be mostly the sludge, means the, like, for example, in field, I'm unable to give you examples from the field, but like dye, you know this. There are, okay. If from any textile industry, they will use some dye to color the textile. So when this dye is coming out, it will contain very high organic carbon load. Okay, the dye will be like red color, blue color, pink color, whatever color. It will not be very turbid. It will be very transparent, but it will contain very high carbon load. So carbon carbon, due to this carbon carbon bond, mostly this thing comes. Okay, so when we are using manure, there will be cow dung, anything, there will be some carbon, but not very very high. Okay, so that is the difference. When we talk about very high carbon load, we mean mostly coming from sugar industry, paper industry, these things. Okay. Anyway, most of the domestic wastewater, agricultural wastewater, they contain less carbon load, more of nutrients load. But industries, it's opposite. Very less nutrients or no nutrient, but mostly carbon load. Okay, we'll move towards next question. Wastewater may be considered as a resource for the recovery of water, nutrients, energy, or all of the above. And you have to tell why, how water is coming, how nutrients, how, where we will use nutrients, where we will use energy, how we will recover it. Anything you know about all these things.
The water can be, after treatment, it can be reused for agriculture purposes or in boilers, industries, thermal power plants,
Correct,
and
correct.
nu- nutrients. The sludge generated after the wastewater treatment can also be used as a fertilizer.
Okay.
So
Energy?
there we can use the nutrients.
Yes, correct,
Energy can be generated in case of anaerobic treatment,
correct,
where we
correct.
can create some gases which can be
Methane.
used as energy.
Correct. Very good. Very good. There are many small treatment plants in India and abroad where the this generation of energy for the running these machines, activated sludge processes, very highly energy intensive processes. The energy for running these machines comes from the treatment plant itself. They will put they will at the end they will do some anaerobic treatment. They will store all the gas in gas storage unit, and they will use this gas for the treatment, for the energy generation. And in some places the kitchen, which is nearby area of these plants, use that energy only, the methane or any these things. So coming to the next question, which of the following is true for centralized and decentralized wastewater management system? Please answer this question. Okay, we'll see the answer. So the answer is A, correct. Large wastewater treatment plant is needed in centralized system. So what is centralized and decentralized system? Just say if in an area there are these many places, these can be homes, these can be schools, hospitals, railway station, anything, and all of them are sending their wastewater through a pipe system at a particular location, treatment plant. So this is called what we call centralized treatment plant. But if there are homes which have their individual septic tank can also be considered as a very small unit of decentralized system. Or if like three homes they have one system, then other few homes they have one system. So this is called decentralized system. In decentralized system, small treatment plant will be needed. Many in number, but small treatment plant. In centralized system, one large treatment plant is needed. And in case of centralized system, the water, even if it's 12 kilometer, 10 kilometer, 50 kilometer, water pipe has to be laid for such large distances. But in decentralized system, small pipe network is enough. Third option is pressure sewage can be obtained in centralized system. In centralized system, water is coming from far. So how can the sewage be fresh? It won't be fresh. It will be smelly. It will be dark in color. So it will be difficult to handle as well. Oxygen content will be very less. Recycling of wastewater is always easier in centralized system. No, in case of decentralized system, if three, just for example, these three locations are using, so we can easily recycle the water and distribute it for whatever purpose we want. For example, agricultural purpose. But in decentralized system, the most common and easiest process is they will treat the water and they will discard the water in nearby river, because there is no infrastructure to return back this water. It's already very costly. All right, nicely. So this is the way how centralized and decentralized wastewater management system works. So actually, it's if by looking at these statements, it sometimes looks like a decentralized system is very good, but in reality, it's not always good. It depends upon the situation where we are in. For example, in case of village where there is very less electricity, if we are giving decentralized system, it will be very difficult to manage. So it depends upon the cost of electricity, cost of the labor, everything. In decentralized system, more labors will be required. So it may sometimes, if there is lack of fund, it may put some pressure on the a municipality. So what will happen? They will shut down some treatment plant. When they will shut down some treatment plant, it's gone. It is not serving the purpose. Or they will divert the water to other treatment plant. So eventually, decentralized system will be converted to centralized system. So this is the problem. So it depends upon the society. It depends upon the financial status or the city plan. Most importantly, city plan, that centralized or decentralized, whichever is good. Moving towards next question. Which among the following is the consequence of discharging untreated wastewater into water bodies? You can answer this question. Okay, we'll see the solution for this question. It's correct. All of you are correct. It's all of the above. When we are discharging untreated wastewater, as I have already explained, it contains pathogens. So it is very harmful for human health. Okay. Second, it may contain nutrients. I'll write here pathogens. Second, it may contain nutrients like nitrate, phosphate. So it may increase the nutrient level of the water body. Means if we are discharging such water body, such type of water in lakes, it will increase the nutrient level of the water body. When the nutrient level increases, we see algal blooms. Okay, so what is algal bloom? Due to increase in nutrient of the water body, there will be growth and development of the small microscopic plants. Okay, this will form a layer of algae over the water body. So what may happen? Is there anyone who can tell what is the harmful effect of or negative effect of eutrophication in algal bloom?
These algal blooms will consume more oxygen from the water, and the dissolved oxygen will become less, and it is harmful to the aquatic ecosystem.
Okay, very good, very good. So what will happen? They will form a mat. Sunlight is not coming. Sunlight won't penetrate inside the water body. So inside plants won't be able to perform photosynthesis. So they will die. Algae are also consuming oxygen. Okay. So oxygen is reducing, but no one is there to produce oxygen. So eventually all the animals or the plants present inside the water body, they will be gone. So this is the problem related to eutrophication and algal bloom. The option is potential effect on economic activities like fisheries, aquaculture, inclusive agriculture. So if a tourist is coming, if they will see a black or green water, they won't be going inside. So and it won't look good as well. So that is why economy will be reduced. There are no fishes, so fisheries gone, aquaculture gone, and tourism and agriculture I already explained. So all of these are the harmful effects of the eutrophication of discharging untreated wastewater into the water body. Sometimes even if the water is not treated properly, it may contain some nutrients. So that may also call eutrophication, but the other problems won't be there. Very less eutrophication, very short ranged, short duration eutrophication, but it may cause some. Next question is, which of the following is India's central government program dedicated at improving sanitation status of the country? All of you are well aware of this. You are hearing it everywhere. So it's correct. Swachh Bharat Mission. So, any doubt, any questions? This is all for today. Next week we'll see week 2. So, in case of any question, you can ask now, or I'll share my website. You can ask questions there also in between week.
I have a question, ma'am.
Yeah, ask.
Ma'am, the questions in which we are dealing with the molecular weight, uh, I want to just know that where these things are applicable in the wastewater treatment.
These things are applicable everywhere. First of all, let's talk about biological treatment because that is the most important treatment in the water. So, in case of biological treatment, let's say you will study it further. Like you are doing BTech.
Ma'am, I am a working professional in public health department.
So you might have already known all these things. See,
Yes.
let's talk about any biological thing. Just for example, this is ASP. ASP means activated sludge process. So there will be in ASP, bacteria or microorganisms are working. So first of all, we like some, and there will be some incoming concentration, some wastewater. Let's say some incoming BOD, some outgoing BOD. So uh, just to maintain uh, for any in biological treatment to treat any amount of BOD, we need to maintain a particular microbial concentration. How this particular microbial concentration can be maintained? This is where mass balance comes into picture. We know how much BOD is coming, how much BOD is going, and in ASP there is one concept to maintain this microbial balance is recirculation of flow. So these all things, there will be many arrows coming, going. So just to find out, this is one thing to find out how much microbial concentration we should maintain to get the desired BOD. There here mass balance is used. So this is one of the examples. And coming to gas generation, how much sludge or we say methane formation potential is coming. Okay, how much gas we can generate from them. So these things also are depending upon the mass balance. And if we talk about any modeling thing, see if let's say we were talking about eutrophication, right? So let's say we have a lake, some nitrate is coming. So if we can correlate, if we can somehow correlate this incoming nitrate and the nitrate which is used in the making of algae, okay, if we can somehow correlate, so we can stop this eutrophication before the algal bloom if we can remove certain amount of nitrate from them. Okay, so this is where mass balance comes into picture.
Okay, ma'am. Ma'am, is there any formula for calculating the sludge, how much sludge is to be wasted and how much is to be recirculated?
Yeah. Bilkul. Bilkul. There is when you will come to ASP, activated sludge process,
Yes,
you
ma'am.
will get a whole list of formulas, how much it should be circulated, how much to waste it, how much for wasting, what will be the degree of treatment, everything you will get. Recirculation ratio, everything.
Okay, ma'am. Thank you.
Thank you. Any more questions? If there are no questions, we'll stop. And I have given
Hello,
my yeah, yes, Uttam.
ma'am. Is there any books to read this course in Hindi?
In Hindi, I don't know. You can prefer some YouTube channels. In YouTube, they are teaching in Hindi.
Okay,
Books,
ma'am.
I
Okay.
don't know in Hindi, but in YouTube channels, you will find something. Definitely, you will find something.
Okay, ma'am. Thank you.
Okay. Thank you. Anything else? Okay. So, thank you, everyone. We'll stop now.
Thank you, madam.
Yeah, we will stop now. So, in case of any question in between week, you can ask in my website. I'll reply and see you next week. Okay. Bye bye. Thank you.
Okay, ma'am. Thank you, ma'am.